EPR nuclear reactor. The EPR is a third-generation pressurized water reactor design. It has been designed and developed mainly by Framatome, part of Areva, between 2001 and 2017, and Électricité de France (EDF) in France and Siemens in Germany. In Europe, this reactor design was called European Pressurized Reactor, and the internationalized name was Evolutionary Power Reactor, but it is now simply named EPR. The first operational EPR unit was China's Taishan 1, which started commercial operation in December 2018. Taishan 2 started commercial operation in September 2019. The first two EPR units to start construction, at Olkiluoto in Finland and Flamanville in France, are both facing costly delays to 2022 and 2023, respectively. Two units at Hinkley Point in the United Kingdom received final approval in September 2016 and are expected to be completed around 2026. EDF has acknowledged severe difficulties in building the EPR design. In September 2015, EDF stated that the design of a new model EPR was being worked on, which will be easier and cheaper to build. Design. First, EPR design. The main design objectives of the third-generation EPR design are increased safety, while providing enhanced economic competitiveness through improvements to previous pressurized water reactor designs scaled up to an electrical power output of around 1650 MWe net, with thermal power of 4500 MW. The reactor can use 5% enriched uranium oxide fuel, reprocessed uranium fuel, or 100% mixed uranium-plutonium oxide fuel. The EPR is the evolutionary descendant of the Framatome N4 and Siemens power generation division convoy reactors. Siemens ceased its nuclear activities in 2011. The EPR was designed to use uranium more efficiently than older generation Roman II reactors, using approximately 17% less uranium per kilowatt-hour of electricity generated than these older reactor technologies. The design had gone through a number of iterations. The 1994 conceptual design had a power output of 1450 MWe, the same as the Framatome N4, but using Siemens convoy-derived instrumentation and including a new core catcher safety system. In 1995, there was concern over excessive cost per MW, and output was increased to 1800 MWe in the 2007 design, though this was subsequently reduced to 1650 MWe in the final certified design. The EPR design has several active and passive protection measures against accidents. 4 independent emergency cooling systems, each providing the required cooling of the decay heat that continues for 1 to 3 years after the reactor's initial shutdown, i.e., 300% redundancy. Leak-tight containment around the reactor. An extra container and cooling area if a molten core manages to escape the reactor. See containment building and core catcher. 2-layer concrete wall with total thickness 2.6 m, designed to withstand impact by aeroplanes and internal overpressure. The EPR has a design maximum core damage frequency of 6.1 x 10^7 per station per year. The EPR has a single steam turbine capable of using all the steam generated. New model EPR design. In 2013, EDF acknowledged the difficulties it was having building the EPR design, with its head of production and engineering, Hervé Machinod, saying EDF had lost its dominant international position in design and construction of nuclear power stations. Machinod indicated EDF was considering designing 2 new lower-powered reactors, one with output of 1500 MWe and the other 1000 MWe. Maginot stated there would be a period of reflection on the best way to improve the EPR design to lower its price and incorporate post-Fukushima safety improvements. In September 2015, EDF Chief Executive Jean-Bernard Lévy stated that the design of a new model EPR, or EPR2, was being worked on, which will be easier to build, to be ready for orders from about 2020, describing it in 2016 as a reactor offering the same characteristics as today's EPR, but it will be cheaper to build with optimized construction times and costs. In 2016, EDF planned to build 2 new model EPR reactors in France by 2030 to prepare for renewing its fleet of older reactors. However, following financial difficulties at Areva and its merger with EDF, French Ecology Minister Nicolas Hulot said in January 2018, for now building a new model EPR is neither a priority or a plan. Right now the priority is to develop renewable energy and to reduce the share of nuclear. The industry government plan for 2019-2022 included work on a new version of the EPR. In July 2019, the French Nuclear Safety Authority ASN issued an opinion on the safety of an outline EPR new model EPR2 design. It found that general safety was on the whole satisfactory, though identifying areas for further examination. The most notable simplification is a single-layer containment building as opposed to the EPR double layer. ASN highlighted that the EPR design basis assumption that primary and secondary cooling circuit piping could not fail may no longer be appropriate for the simplified EPR2 and requires additional safety demonstrations. In 2020, Energy Minister Elizabeth Bourne announced the government would not decide on the construction of any new reactors till the much-delayed Flamanville 3 started operation after 2022. EDF had estimated building 6 EPR2 nuclear reactors would cost at least €46 billion. A Court of Audit report concluded that EDF is no longer able to finance EPR2 construction on its own, so financing and profitability issues need to be resolved. The Audit Office requires that EDF must ensure financing and profitability of EPR2 before constructing any in France. Olkiluoto 3, Finland. The construction of the Olkiluoto 3 power station in Finland commenced in August 2005. The station will have an electrical power output of 1600 MWe net. The construction was a joint effort of French Areva and German Siemens AG through their common subsidiary Areva NP for Finnish operator TVO. Siemens ceased nuclear activities in 2011. Initial cost estimates were about €7 billion, but the project has since seen several severe cost increases and delays, with latest cost estimates from 2012 of more than €8 billion. The station was initially scheduled to go online in 2009, but operations are now expected to start in 2022. In May 2006, construction delays of about 1 year were announced, following quality control problems across the construction. In part, the delays were due to the lack of oversight of subcontractors inexperienced in nuclear construction. The delays led to disappointing financial results for the Areva NP. It blamed delays on the Finnish approach to approving technical documentation and designs. In December 2006, TVO announced construction was about 18 months behind schedule, so completion was now expected 2010-11, and there were reports that Areva was preparing to take a €500 million charge on its accounts for the delay. At the end of June 2007, it was reported that Säteilyturvakeskus, the Finnish Radiation and Nuclear Safety Authority, had found a number of safety-related design and manufacturing deficiencies. In August 2007, A further construction delay of up to a year was reported associated with construction problems in reinforcing the reactor building to withstand an aeroplane crash, and the timely supply of adequate documentation to the Finnish authorities. In September 2007, TVO reported the construction delay as at least 2 years and costs more than 25% over budget. Cost estimates by analysts for the overrun range up to €5 billion. A further delay was announced in October 2008, making the total delay 3 years, giving an expected online date of 2012. The parties are in arbitration to resolve a dispute over responsibility for the delays and final cost overruns. As of May 2009, the station was at least 3.5 years behind schedule and more than 50% over budget. Areva and the utility involved are in bitter dispute over who will bear the cost overruns, and there is a real risk now that the utility will default. In August 2009, Areva announced €550 million additional provisions for the build, taking station costs to €3 billion, and wiped out interim operating profits for the first half year of 2009. The dome of the containment structure was topped out in September 2009. 90% of procurement, 80% of engineering works, and 73% of civil works were completed. In June 2010, Areva announced €400 million of further provisions, taking the cost overrun to €7 billion. The timescale slipped from June 2012 to the end of 2012. In December 2011, TVO announced a further delay to August 2014. As of July 2012, the station was scheduled to start electricity production no earlier than 2015, schedule slippage of at least 6 years. In December 2012, Areva's chief executive estimated costs to €8 billion. In September 2014, Areva announced that operations would start in 2018. In October 2017, the date was pushed back to the spring of 2019. During testing in 2018 and 2019, multiple further delays were announced, of almost 2 years in total. In August 2020, the commissioning schedule was revised again. Regular electricity generation is due to start in February 2022. Flamanville 3, France. First concrete was poured for the demonstration EPR reactor at the Flamanville nuclear power plant on 6 December 2007. As the name implies, this will be the third nuclear reactor on the Flamanville site, and the second instance of an EPR being built. Electrical output will be 1630 MWe net. The project was planned to involve around €3 billion of capital expenditure from EDF, but latest cost estimates from 2019 are at €4 billion. Pierre Moscovici, president of the Court of Audit, gave a statement on 9 July 2020 concerning the release of the report on the delay costs of the Flamanville 3. The report of the Court of Audit reveals that the cost of Flamanville 3 could reach €1 billion when taking in account the additional charges due to the delay in construction. From 19 October 2005 to 18 February 2006, the project was submitted to a national public debate. On 4 May 2006, the decision was made by EDF Board of Directors to continue with the construction. Between 15 June and 31 July 2006, the unit underwent a public inquiry, which rendered a favorable opinion on the project. That summer, site preparation works began. In December 2007, construction of the unit itself began. This was expected to last 54 months, with commissioning planned for 2012. In April 2008, the French nuclear safety authority Autorite de Short Nucléaire (ASN) reported that a quarter of the welds inspected in the secondary containment steel liner are not in accordance with norms, and that cracks have been found in the concrete base. EDF stated that progress was being made on these issues, which were raised very early in construction. However, on 21 May, ASN ordered a suspension of concrete pouring on the site. A month later, concreting work resumed after ASN accepted EDF corrective action plan, which included external oversight checks. In May 2009, Professor Stephen Thomas reported that after 18 months of construction, and after a series of quality control problems, the project is more than 20% over budget, and EDF is struggling to keep it on schedule. In August 2010, the regulator, ASN, reported further welding problems on the secondary containment steel liner. The same month, EDF announced that costs had increased 50% to EUR 5 billion, and commissioning was delayed by about 2 years to 2014. In July 2011, EDF announced that the estimated costs had escalated to EUR 6 billion, and that completion of construction was delayed to 2016. On 3 December 2012, EDF announced that the estimated costs had escalated to EU rate 5 billion. In December 2012, the Italian power company Enel announced it was relinquishing its 12.5% stake in the project, and 5 future EPR so would be reimbursed its project stake of EUR 613 million plus interest. In November 2014, EDF announced that completion of construction was delayed to 2017 due to delays in component delivery by Areva. In April 2015, Areva informed the French nuclear regulator ASN that anomalies had been detected in the reactor vessel steel, causing lower than expected mechanical toughness values. Further tests are underway. In July 2015, the Daily Telegraph reported that Areva had been aware of this problem since 2006. In June 2015, multiple faults in cooling system safety valves were discovered by ASN. In September 2015, EDF announced that the estimated costs had escalated to EUR 10.5 billion, and the startup of the reactor was delayed to the fourth quarter of 2018. In April 2016, ASN announced that additional weak spots had been found in the reactor steel, and Areva and EDF responded that new tests would be conducted, though construction work would continue. In February 2017, the Financial Times stated the project was 6 years late and EUR 7.2 billion over budget, while renewed delays in the construction of the EPR reactors at Taishan nuclear power plant prompted EDF to state that Flamanville 3 remains on schedule to start operations by the end of 2018, assuming it receives regulatory approval. In June 2017, the French regulator issued a provisional ruling that Flamanville 3 is safe to start. The discovery of quality deviations in the welding led to a further revision of the schedule in July 2018. Fuel loading was delayed until the end of 2019, and the cost estimate was increased from EUR 10.5 billion to EUR 10.9 billion. In June 2019, the regulator ASN determined that 8 welds in steam transfer pipes passing through the 2-wall containment that EDF had hoped to repair after startup must be repaired before the reactor is commissioned. In October 2019, EDF announced that because of this issue, costs would increase to EUR 12.4 billion and that fuel loading would be delayed until the end of 2022, with regular electricity generation starting in 2023 at the earliest. Taishan 1 and 2 China. In 2006, Areva took part in the first bidding process for the construction of 4 new nuclear reactors in China, together with Toshiba-owned Westinghouse and Russian Atomstroy Export. However, Areva lost this bid in favor of Westinghouse's EP1000 reactors, in part because of Areva's refusal to transfer the expertise and knowledge to China. Subsequently, Areva managed to win a deal in February 2007 worth about €8 billion, $5 billion for two EPR located in Taishan, Guangdong Province in southern China, in spite of sticking to its previous conditions. The general contractor and operator is the China General Nuclear Power Group (CGN). Construction of the first reactor at Taishan started officially on 18 November 2009 and the second on 15 April 2010. Construction of each unit was then planned to take 46 months, significantly faster and cheaper than the first two EPR in Finland and France. The reactor pressure vessel of the first reactor was installed in June 2012 and the second in November 2014. The first pressure vessel had been imported from Mitsubishi Heavy Industries in Japan and steam generators from Areva in France. The second pressure vessel and associated steam generators had been made in China by Dongfeng Electric and Shanghai Electric. In 2014, construction was reported to be running over 2 years late, mainly due to key component delays and project management issues. Cold function tests were performed on Taishan 1 in February 2016, with startup expected in the first half of 2017. Taishan 2 was scheduled to start up later that year. However, commissioning dates were put back 6 months in February 2017, with commercial operation expected in the second half of 2017 and the first half of 2018. In December 2017, Hong Kong media reported that a component had cracked during testing, needing to be replaced. In January 2018, commissioning was rescheduled again, with commercial operation expected in 2018 and 2019. In June 2018, Taishan 1 achieved criticality for the first time. It entered commercial operation in December 2018. Taishan 2 reached these milestones in May 2019 and September 2019, respectively. The Taishan project is led by Taishan Nuclear Power Joint Venture Company TNPJVC, a joint venture founded by CGN, 51% ownership stake, EDF 30%, and Chinese utility Guangdong Energy Group 19%, also known as Euedian. Companies involved in supplying equipment to Taishan Unit 1 include Framatome, which manufactured the steam generators and pressurizer in France, and China's Dongfeng Electric Corp. DEC, which manufactured the Areva turbine in the engine room. That turbine was designed and licensed by General Electric. Other equipment suppliers for Unit 1 include Mitsubishi Reactor Vessel, Skoda, a Czech company, Core Internals, and France's Dumont Electric, which along with DEC provided primary pumps. On 14 April 2020, Framatome signed a long-term service contract with the Taishan Nuclear Power Joint Venture Company Limited (TNPJVC) to support operations of 2 EPR, the Taishan Nuclear Power Plant in China. This contract covers nuclear plant outage and maintenance work, including spare parts supply and engineering services, for 8 years. Hinkley Point C, United Kingdom. The EPR underwent generic design assessment by the Office for Nuclear Regulation, along with the Westinghouse EP1000. Interim design acceptance confirmations were postponed until lessons from the Fukushima Daiichi nuclear disaster had been taken into account. EDF bought British Energy in 2009. EDF planned to build 4 new EPR, subject to electricity pricing agreement with the government. Areva has signed a strategic partnership with Rolls-Royce to support the build of EPR. On 19 March 2013, planning consent for Hinkley Point C nuclear power station was given. Difficult negotiations with the UK government about electricity pricing and project financing with private investors still needed to be concluded. On 21 October 2013, EDF Energy announced that an agreement had been reached regarding the nuclear stations to be built on the site of Hinkley Point C. EDF Group and the UK government agreed on the key commercial terms of the investment contract. The final investment decision was conditional on completion of the remaining key steps, including the agreement of the European Commission. On 8 October 2014, the European Commission announced their agreement, with 16 out of 28 commissioners agreeing with the go-ahead of the construction. On 21 September 2015, the British government announced it would provide a PS2 billion support package for Hinkley Point C as Britain's first nuclear power station in 20 years. On 21 October 2015, during Chinese President Xi Jinping's state visit to the United Kingdom, EDF and CGN signed an investment agreement for the PS18 billion, EUR 20 billion project to build 2 reactors at Hinkley Point. However, legally binding contracts had not been agreed yet. In June 2016, EDF managers told members of Parliament that the Hinkley Point C proposal should be postponed until it has solved a litany of problems, including EDF's soaring debts. On 28 July 2016, after the resignation of a board member, the EDF board approved the project. However, Greg Clark, the new Secretary of State for Business, Energy and Industrial Strategy in the new government of Theresa May, then announced that the government would not sign the contract over the next few days as expected, but delay the contract to autumn to consider carefully all the component parts of this project. Final government approval was given in September 2016. In July 2017, following an internal review, EDF announced revised estimates for the scheme, which included at least P-zone 5 billion of additional costs and up to 15 months of additional program, leading to updated total cost estimates of P-19 620 3 billion EUR 21 922 6 billion. In September 2019, cost estimates were revised again to between PS21 5 and PS22 5 billion EUR 2425 1 billion. Possible future power stations. France. In July 2008, the French president announced a second EPR would be built in France due to high oil and gas prices. Penly was chosen as the site in 2009, with construction planned to start in 2012. However, in 2011, following the Fukushima Daiichi nuclear disaster, EDF postponed public consultations. In February 2013, the Minister of Industrial Renewal Arnaud Montebourg stated that the plans for a new EPR reactor at Penly had been cancelled, citing the capacity for electricity production and massive investments in renewable energy, along with his confidence in the EPR as a competitive project in foreign countries. Plans to build new reactors in France were later revived. In 2019, EDF plans to select a site for the installation of a pair of EPR reactors. Penly and Gravelines are among the candidates. In October 2019, newspaper Le Monde reported that the French government had sent EDF a mission letter in which it asked the company to prepare to build a total of 6 EPR reactors across 3 sites in the next 15 years. India. In February 2009, the Nuclear Power Corporation of India (NPCIL) signed a Memorandum of Understanding with Areva to set up 2 EPR reactors at Jadavpur in Maharashtra. This was followed by a framework agreement in December 2010. In January 2016, during French President François Hollande's state visit to India, a joint statement with Indian Prime Minister Narendra Modi was issued. According to the statement, the two leaders have agreed on a roadmap of cooperation to speed up discussions on the Jaipur project. On 10 March 2018, an industrial way forward agreement between EDF and NPCIL was signed, with an objective of producing a tender for 6 reactors. In April 2021, EDF submitted to NPCIL an offer to develop 6 EPR reactors at the Jaipur site, with a combined installed capacity of 9.6 GW. United Kingdom. 2 EPR units at Sizewell, Suffolk are in the early stages of planning. In May 2020, EDF Energy applied for a development consent order. If the project goes ahead, electricity production is expected to start in 2031 at the earliest. 2 further EPR units have been proposed for construction at the Moorside site near Sellafield, Cumbria, as part of a future clean energy hub that would also incorporate modular reactors, renewable energy generation, hydrogen production, and battery storage technologies. Unsuccessful proposals. Canada. EPR was considered for the 2 possible expansion to 4 reactor addition to the Darlington Nuclear Generating Station in Ontario, Canada. However, the official bids had to include all contingencies, and Areva failed to enter a final bid meeting these requirements. The project was ultimately abandoned when the only bid, made by Canada's ECOL, came in at well over $10/WP. EPR was briefly considered for an installation in New Brunswick, replacing or supplanting that province's single CANDU 6. These plans lasted only from June 2010 until an election 2 months later, when the plan immediately disappeared from further study. Czech Republic. In October 2012, CEZ announced that Areva was eliminated from the tender for the construction of 2 reactors for Temelin nuclear plant. Areva failed to comply with legal requirements of the tender. In April 2014, CEZ cancelled a tender because of low power prices and the government's refusal to support a minimum guaranteed energy price. Finland. In 2010, the Finnish parliament decided to allow 2 new reactors. Both TVO and Fennovoima were considering the EPR. In December 2013, Fennovoima confirmed it had selected a Russian AES 2006 Viver pressurized water reactor in preference to the EPR. Italy. On 24 February 2009, Italy and France agreed to study the feasibility of building 4 new nuclear power stations in Italy. Following this, on 3 August 2009, EDF and Enel established a joint venture, Sviluppo Nuclear Italia, to study the feasibility of building at least 4 EPR. However, in the 2011 referendum, soon after the Fukushima nuclear disaster, Italians voted to repeal the new regulations permitting nuclear power in Italy. Abrogation of laws is put in effect when at least 50% plus 1 electors make a valid vote and a majority of these voters are in favor of abrogation. In this referendum, there was a 55% valid voter turnout and 94% voted to abrogate the new regulations. United Arab Emirates. In March 2008, French President Nicolas Sarkozy reached an agreement with the UAE cabinet that outlines a cooperation framework for the assessment and possible use of nuclear energy for peaceful ends. This agreement was not a contract for EPR construction by any of the French nuclear companies Total SA, Suez, or Areva. In May 2009, U.S. President Barack Obama signed a similar agreement with the UAE. Contracts for reactors were not given, nor was there any guarantee made that U.S. companies would receive them. In December 2009, the United Arab Emirates declined both the American and French bids and awarded a contract for construction of 4 non-EPR stations, APRA 1400, to a South Korean group, including Korea Electric Power Corporation, Hyundai Engineering and Construction, Samsung and Doosan Heavy Industries. After losing this order, Areva considered whether it should reintroduce the marketing of a smaller and simpler second-generation reactor design alongside the EPR for countries that are new to nuclear power. As of 2011, Areva and Mitsubishi Heavy Industries offer a smaller 1100 MWe Atmi Aeon generation Roman 3 PWR. United States. The U.S. EPR, the version of the EPR submitted to the U.S. regulator, is one of the competitors for the next generation of nuclear stations in the United States, along with the APON 1000 and the SBOR. In February 2015, Areva asked to suspend the design certification application review process at the U.S. Nuclear Regulatory Commission (NRC). It had been under review there with expectation to submit an application for final design approval and standard design certification since 14 December 2007. Unistar, Amarillo Power, PPL Corp., and Ameren UE announced plans to file a combined construction and operating license application in 2008 for the U.S. EPR at its Callaway station. Unistar filed a partial application in July 2007 for a proposed third unit at the Calvert Cliffs nuclear power plant in Maryland. However, both proposals were subsequently canceled. In April 2009, Missouri legislators balked at pre-construction rate increases, prompting Ameren UE to suspend plans for its reactor. In July 2010, Constellation Energy Group cut spending on Unistar for the Calvert Cliffs nuclear power station because of uncertainties for a loan guarantee from the U.S. Department of Energy, and subsequently pulled out of the project. In October 2008, Areva announced that it will partner with U.S. defense firm Northrop Grumman to establish a $380 million facility to construct modules and assemblies for the EPR and U.S. EPR reactors at Northrop Grumman's Newport News shipyard in Virginia. The project was suspended indefinitely in May 2011.